So I've decided to add 3 LEDs to the board just because I like blinking lights, and I've modified the schematic here to represent what I want to do. I want an LED lights up when the board itself is selected, so it'll come off this, what I call the output enable signal here. I want an LED that'll light when we're actually doing reads. So this read signal will tie up to here, the little dot. Didn't actually do that consistently. It should have been there, and there should not be a dot inside of this one. So we will fix that on the schematic. Little dots indicate board interconnects. Non-dots indicate it goes off the board. So there'll be an LED that'll indicate that we are actually reading from the device. And then I want one for the weight, where the board's actually generating a weight. So I've got the 3 LEDs. Let's go ahead and test them at 5 milliamps. These are new old stock. I don't want them super bright. I don't like the super bright LEDs, and it's just not period accurate. You know, those have got a nice red to them. So I think the 3 of those will work. I've spec'd 330 ohm resistors. I hope that'll be sufficient. And I have these unused gates, these 1897s. I'm just going to use 3 of those to buffer, to actually create the drive for the LED. So the first thing here is to kind of figure out how the LEDs are going to get mounted. It'd be nice to have them up here high on the board. That might actually work. Figure out some spacing here I like. That'll actually work. I don't like the fact that I'm really close to this minus 9 volt bus here. I will, I think, put some tape over that just to insulate it. But let's tack those in place. Just call that a start. Already see that they're not in straight just by the way the pins are. I'll only solder 1 pin. I'll pull the tape off and come back and make sure they're in flush. Obviously the way they wiggled around they're not, although they look okay. I'm gonna go ahead and flush them up. I'm just reflowing the solder and pressing the LED up tight against the PCB. So that works. I'm happy with that. I've got the 3 LEDs that'll jumper these to the power rail, and I've got a plus 5 volt rail there. I'm gonna, I think, jumper on the back of the board. That way I've got room here to get paper labels on the front here for what those 3 LEDs stand for. The only issue here is electrical tape, and I do have a fresh roll. I am going to use this to just cover up that 9 volt bus. If I can get the tape to actually come off the roll here without stretching too much. Piece about a long, and it's a little bit too wide, I think, so we will trim it down. I'm just going to go ahead and do that. I wish I'd have made it a little bit longer. So we'll redo that because I'm not happy with it. And it actually covered up a 5-volt bus, so that wasn't going to work for me anyhow. So let's go with a little bit more length, actually a lot more length. And I need to basically split it down the middle. A little too long now, which is okay. That covers up that 9-volt power rail up here just so it doesn't accidentally sneak back onto the TTL logic on the board and cause me issues. I've got the flats to the right, which means the leads that are unsoldered are going to be the power. So let's figure out here how we're going to do this. I think the way I'm going to do it is I'm going to bend that lead down slightly. Where's the needle nose pliers? Wonder what they're barking at now. Always barking at something. One, two, and three. We'll get some solder here on the 5-volt bus. About the position I want to tack these down. Tack this one into position. That one. Why do I keep ending up with it upside down? That one, and that should pick up 5 volts. as always, kind of think ahead about the best way to do this. There's always a million options. Let's see if I can just get that lead kind of into where I want it. Can take a little bit more off though, so I'm not super close to that ground. Don't need a 330 ohm resistor between power and ground. That wouldn't really do anything useful. Just kind of get those down in place. We will solder those up. Hopefully I got those in the right direction. Yeah, the flats are all this side of the board, and it looks pretty good. Oops. Wouldn't be on the bench if it wasn't dropping stuff on the floor. I think I can trim those a little bit more, just to kind of get that sharp pin down. And really now it's a matter of, I think, wire wrap work. To get this done. So I need some black wrap wire and the wrap tool. And we're going to take on device G, which is way down here, which is kind of sad it's that far away, but that's where the buffer is. We're going to take device G, pin 1, it needs to be grounded to enable that buffer. It'll just always be enabled. G, pin 1. And I've actually got a pin already tied to ground over here, so I'm just going to wrap onto that post. Wow, that's awfully long. Doesn't need to be near that long. Need the wrap wire to actually stay inside of the tool. There it goes. Not the best wrap joint I've ever done. But that grounds pin 1. Let's use, I guess, red. How do I want to use red? Kind of run out of colors here. Let's take the yellow wrap wire. I need to trim these pins down a bit. That, get it started, relax my fingers, the tension on the wire pulls it right back out of the tool. I'm gonna wrap onto that LED post. I want this to be board enable. So it's going to come around to pin 3 on device G. Starting to get a real rat's nest on the back of the board here. That's going to come over to pin 3. We'll add another wire. For read in the middle. Read in the middle goes along to pin 5. Got a dog super excited out there for some reason. So along to pin 5. I will eventually put some wires kind of through holes to hold these wires down flush against the board. Give them some relief. And the final one is going to be weight. Oh, stop it out there. And the weight is going to go to pin 7. Yes, Anna, I hear you being silly. Well, she went back downstairs. It's amazing how often that's happening to me, where I just release the tension on my fingers a tad bit, and the wire just has a mind of its own. It's pin 7. Once you guys kind of all wrapped around here, the same basic path. Might have a little tidbit of wire standing up. I'm going to solder these over here onto the LED pins. And I'm going to trim those pins down. Now it really becomes picking up the signals to drive those 3 places. And we'll do yellow here again. So we're going to have device A, pin 8. It's already got a number of wraps on it. Goes to device B, which is down here, pin 12. I'll pick it up there. Probably off camera here, sorry. So I'm going to get to pin 2 here. Nope, that did not wrap right. The wrap wire popped up out of the channel in the tool and wrapped around the barrel and broke. Pin 2 here goes to output enable, and we're going to go ahead and just pick that up from pin 12 of device B. Make sure it kind of makes sense here. It does. Up to pin 12. And pin 4. It's going to come to read, which is device D, pin 3. Device D is sitting right here. Device D, pin 3. That should indicate that we're actively reading from the board. And pin 6 goes to wait. Pin 6 down here. Is going to go to wait, and that's pin 9 on the device C right here. And pin 9 currently doesn't have anything connected to it. It is the Q output, and the Q not outputs what's used to drive the P ready on the bus. That's going to go up there to pin 9, and I need the signal to be low to turn the LED on, and P ready is driven high. So the Q output should work just fine for this. Of course, that assumes I can find the wrap tool. And that's going to come up here to pin 9. That is device C, pin 9. And assuming I haven't done anything stupid, we've got 330 ohm resistors going to the positive side of the LEDs. We've got the negative side coming down to the drivers. That should hopefully work. So with that, I didn't realize I had so much glare on the paper from the sun. Sorry about that. With that, I will take the board downstairs, plug it in the machine, and see if the LEDs blink. So I've got the board in the system. I realized after wire wrapping it that I actually needed to go to pin 8 on the flip-flop to generate the wait signal. So I moved that wire off the video. Let's go ahead and apply power and see what we get. So, well, we saw a couple LEDs do something. So we're sitting in the front panel, or in the start state of the machine. Let me go ahead and reset the machine. And when I do a reset, all the address pins come to 1s. And that would be why the board enabled LED is lighting. So let's do an examine of address FF00. And we should see the board come active when we did, and it's reading from the board as it should. As I step up to the addresses, it'll continue to read. So let's reset again and do an examine. And I'm not going to go ahead and run the bootloader from FF00. I just don't have the floppies on, and this should just sit in loop, waiting for the drive to come active, and we should see the board wait LED come on here. So let's see what happens. Excellent, and we do. So let me power up the floppy drives now. And I will close the door here, and the machine should boot. I would expect once it's booted, all 3 of those LEDs to go off. And it didn't do that. So what have I got wrong? Oh, I know what I've got wrong. Yeah, that's a wiring issue on the board. Yeah, the flip-flop is actually active all the time. I picked up the signal for the wait LED from the output of the flip-flop, and it really needed to come to think about this. The wait LED is really going to have to come from... The wait LED is really the same signal as board enabled, honestly, thinking about the schematic. So I need to move... I know the wire I need to move here, I believe. Anyhow, so well, 2 out of 3 isn't bad. Yeah, I'm sure that board wait, the signal's toggling up and down is why the LED is active. It's just not getting gated off the board to the bus to tell the machine to wait. So I didn't think about that well before I wired it up. Anyhow, let's stop the machine again. Let's go ahead and examine address FF80 again, and we'll go ahead and run the machine with the floppy drive door open. And we see the machine running. Close the door here, and it should finish booting. And we see activity, really the board enabled and the board read pretty much blink together. I'm just thinking about how to fix this wait issue. Actually, yeah, there's a fix I can do on the board so that the wait LED at least blinks and means something. Anyhow, I will fix that, but I'll wrap this video up here. Hope you enjoyed this, and we'll talk soon.